All right, and hi everybody, welcome back to Mr. Gregorius Math. Today we're going to be talking about normal distributions, specifically on our TI-84 plus CE calculator. So suppose we had a random variable x that was distributed normally, and it had a mean and a standard deviation of sigma, so a variance of sigma squared. So suppose we had this distribution statement and we needed to solve a particular problem about it. Well, a normal distribution looks like this normal curve, and the mean is always at top dead center, and it is symmetrical on either side. So I have a couple of observation levels indicated here. So I have an observation x1 and an observation x2. And I might be asked to answer a question like, hey, what's the probability that x is less than x1? So that would mean, what's the area under the normal curve from there to there? So that particular probability, I would need to know some things. So I'm going to go back to my probability distribution, and I'm going to put in, sorry for the shakiness of the camera, I'm going to put in a couple of things. I'm going to put in a mean of like 3 and a standard deviation of 2. So I'm going to put in my variance of 2 squared or 4. So we're going to take a look at this particular situation. Now that means that my mean up here is going to be at 3, so I'm going to make x1 equal to, I don't know, 2. So what is the probability that x is less than 2 given that distribution? So I go over to my calculator and I press second function, distribution. And I'm going to go to normal CDF because I'm looking for the cumulative or the area underneath the curve. I'm going to normal CDF. I'll never use normal PDF unless I'm looking for the height of the curve and I'm going to do some calculus with it. Now, it's asking me for my lower bound. So that means of this area, where's the boundary to the low side? So I really can use any number, just as long as it's significantly far back from my observation of 2 and my mean of 3. So this has a really, really, really large negative number, but if I just do like negative 1,000, that is going to be significantly far away from my mean. It's many, many, many standard deviations away from the mean. Now my upper bound is my observation because my area is bound at the low spot by negative 1,000 and at the high spot by 2. So I'm going to go to my upper and 2. Now my mean was 3, and you may recall my variance was 4, meaning my standard deviation is the square root of 4 or 2. And I'll just go ahead and click paste and it will tell me my area. So my area here is 30.85%, which means this is 30.85%. Now, there's a couple of other types of questions I could be asked, not just an inequality that looks like this, but suppose I want to know the probability that a result lies between x1 and x2. Now, we said that our mean was 3, and so if x1 is 2, let's make x2 equal to, I don't know, 3.5. Well, here I would be looking for the area underneath my curve. And that area is just going to have a lower bound of 2 and an upper bound of 3.5. So I'll go back to my calculator, second function, distribution. Normal CDF is option 2. Now I'm going to adjust my lower to be 2 and my upper to be 3.5. That way it's going to have 2 as my lower bound and 3.5 as my upper bound. I'll go ahead and keep the same mean and standard deviation and click paste, and it gives me my area. So my area of that particular region is about 29.02. So this area is 29.02%. Now, I realize my drawing's not exactly well drawn to scale, and that's because of the fact that my standard deviation of 2 would be significantly further down. So I made a pretty big change in the height of this curve accidentally. Now, I could also have a probability that a value is greater than a particular amount. So this was in between, and the inequality for that would have been the probability that 2 is less than x is less than 3.5. That would have led me to this region. Now, there's one more type of inequality I could have. I could have the probability that x is greater than, and I'm going to stick with 3.5 here. And so going back to my diagram, if I want the probability that x is greater than 3.5, I need the area underneath this portion of the curve, because it's everything from 3.5 and up. So I'll go back to second function, distribution, normal CDF. And now my lower is the left-hand part of this area, which is 3.5. So set my lower to 3.5. My upper now needs to be significantly large. I could choose any large number, and there really wouldn't be a difference between 100 and 1,000. So I'm just going to use 100. Same mean, same standard deviation. Go ahead and click paste, and that area works out to be 40.13. So this area here is 40.13%. And if I add up 40.13 and 29.02 and 30.85, I should have 100 because I've gone all the way underneath this entire curve. And remember, the area underneath a normal distribution is 1. That's it for using normal CDF.